In this video, I'm going to be talking about genetically modified organisms, or GMOs for short. So what exactly is a GMO? Well, first we have to understand a little bit about DNA. So here is the basic structure of DNA. As you can see, it has a double helix shape, which are the two strands kind of zigzagging back and forth. Now, DNA is separated into smaller segments that code for specific traits. The smaller segments are genes, so maybe from this line to this line over here, that could be one gene. The DNA itself, the double helix strands, are made of nucleotides. A nucleotide, which kind of looks like this drawing over here, is in three parts. It has a sugar, which is the big center, has a phosphate on the top, and has a nitrogen base out towards the side. So basically these nitrogen bases connect to other nitrogen bases on the opposite side. So as you can see, this is a nitrogen base. It'll connect to this nitrogen base over here. And the phosphates hold two sugars of two nucleotides together. Now there's two rules about nitrogen bases. So the nitrogen bases are adenine, thymine, cytosine, and guanine, represented by A, T, C, and G. But adenine and thymine always are opposite from one another. So you can't have an adenine and then a cytosine on the other side. And cytosine and guanine are always on the opposite side from one another. So let's say you have adenine right here. This would have to be a thymine. And if this is cytosine, then this has to be guanine. Okay, so three nitrogen bases in a group makes one codon. So this could be one codon. And a codon codes for one amino acid, and different amino acids combine to make proteins. And proteins determine what you look like and your physical appearance. So DNA is kind of like the code for animals. So now that we know about DNA, we can get to what GMOs are and how they're made. So there's basically 4 steps when you're making a GMO. The first step is to find a weakness in the organism and find the desired trait that you want. So, for example, this tomato, its weakness could be that it spoils. So, a desired trait that you might want to have is you want the tomato to be fresh longer so it can stay like this tomato over here. So, the second step, it can be one of two things. You can either find another organism with that desired trait, or you can modify the DNA of your organism to make it better, to find the desired trait. So the third step is take the modified DNA, or take the DNA from another organism and insert it into the DNA of your original organism. And the way that's done is, first of all, you take different nitrogen bases, which are again adenine, thymine, cytosine, and guanine, and then you insert them with a gene gun that it has a method of putting DNA into organisms, and you insert it into the different codons of the original organism. So then this fourth step is to grow the organism and test it to make sure that there's no negative side effects to the GMO you made. So now we know what GMOs are, but we also have to know that there's a few benefits and a few risks to making GMOs. So the main benefit is that it can make food and organisms healthier and safer for us to use. And another benefit is there can be some economic growth. For example, if you go back to the spoiled tomato that you have, let's say 1/4 of all tomatoes are spoiled, you have to throw those out. So if you GMO all your tomatoes so that they don't spoil, then you have 25% more product to sell. So some of the risks that come with GMOs are, well, GMOs are kind of unknown. We don't really know what's going to happen, and that makes a lot of people scared of them, which can cause kind of a controversy. And a second risk, I guess, of GMOs is that local farmers are not going to have access to GMOs early on, and only the big farms are going to. So it's going to not help local farmers. It's not going to help them sell their food. So now this is my idea for a GMO, and I call it red ivy. So first, some background. All plants have different genes that determine their color, and one of the genes is a skin pigmentation color. So I want to take the red skin pigmentation from a cherry and put it into poison ivy, and as a result, the poison ivy will be red. And if poison ivy is red in a forest of green, then it'll be much easier to spot, so we'll be less likely to get a rash from poison ivy. So now, after I've talked about everything else, I want to talk about stakeholder positions, which are people's opinions, the opinions of people who will be affected by GMOs. So first, let's look at the farmer. There's two different positions that a farmer could have. So for a local farmer, just a family farm, they could have a bad opinion because more people are going to go to GMO farms, big farms like Central Valley in California, and the family farms aren't going to get as much business. But big farms like Central Valley from before are going to have a good opinion because that's going to be um, more product and more money for them. So the industry, the food industry, is kind of going to have a mixed feeling because some customers don't want GMOs because they're scared, and then other customers do. So now it's up to the food industry to decide whether they want to use GMOs in their food or whether they just want to go all organic. So they're kind of split in that sense. And the consumer is almost in the same boat as the industry. They kind of have mixed feelings or they're a little bit split because some consumers want GMOs and some consumers don't. So now there's one last stakeholder position that's not on here, and that is me. I think that GMOs are fine for us, and I don't think there will be any negatives to them because as long as we're careful and as long as we test our GMOs when we make them, then they're completely safe for us, and there's not going to be any negative side effects. So I think that GMOs are a good thing for us to use. And that about wraps up the video. So thank you for watching.